Alright guys, here's an example of a very common fluid mechanic problem that you guys might see in the future, um, where we're trying to model the fluid flow inside of a bioreactor. So imagine we have this bioreactor system here with some type of fluid inside of some volume, alright, and we can model the fluid flow in and out of the system. Alright, where we have coming into our system some type of fluid, F in, and inside of our system we have a particular volume. And then going out at some point, alright, we have that fluid also leaving at some K, which is just a constant, times the height of this particular volume, right? And so pretty standard biofluid or fluid mechanics problem. So we can model this system simply by having an equation, volume times the change in height with respect to time, all right, is going to equal, all right, just a mass balance here, Fn, our fluid coming into our system, minus what's going out, so the rate at which this is leaving, K times H, right? So we talked about the mass balance stuff earlier this semester, but if I were to assume a steady state system, right, then this is going to go to 0, right? And then so I can rewrite this equation as 0 equals Fn minus Kh. And if I were to plot this, all right, as a function of the fluid coming in, right, times the height, or versus the height, all right, I would probably get some kind of system that's gonna, some nonlinear system that's gonna look like this, all right. And if we wanted to determine K, which often you do, you want to try to determine the rate at which this fluid is leaving the system. This would be difficult to do because we have a nonlinear system, right? But we can transform this data, all right, to look at this data in a linear form, all right? And so I can rearrange this equation. I'm going to do that down here to get Fn, all right, it's going to equal, all right, K, and instead of doing K times our height, I'm going to take the square root of our height, all right, and so I'm going to end up squaring or taking the square root of H here, and so this is our linear form, right, where Y is going to equal mx, all right, plus b, which, because our linear line is just going to go through the y intercept at 0, that just means b is equal to 0. That's all. Then if I were to model this, all right, and plot this as a function of f n, all right, versus the square root of h, all right, I then get a linear line that looks something like this, where I can simply calculate the slope here, right? And the slope in this particular case is going to end up equaling my actual rate, K, that I would like to find. So I hope this is helpful, and we'll move on to the next example. Thanks.